Meet Igor Bray. He's tackling 3 of the world's toughest challenges: golf, theoretical physics, and fatherhood. So far he's had a lot of success with physics. At Flinders University in Adelaide, Igor's cracked a 66-year-old puzzle. He's created a mathematical theory that predicts how electrons behave when they are smashed into atoms.
So you work with atoms, right?
Yep.
What are they?
Well, an atom consists of a very heavy sort of dense nucleus. There's one electron.
And his solution has got physicists around the world very, very excited.
And we'd like to fire another electron at this atom.
You see, electrons drive everything electrical.
You might hit this electron really hard, and so much so that they both escape from the proton.
In fact, electrons are electricity. But when you turn the power on, they rush down the wire in a jumbled mess, bouncing around in all sorts of unpredictable ways. So, a lot of electricity is just wasted.
So we just got a laser, which is producing a wavelength of 766.7 nanometers.
In labs like this, experimental physicists have tried to understand how electrons bounce around.
And it just passes down along the chamber, sort of some mirrors and some optics at the end.
They fire electrons at atoms, then carefully note the angle of each bounce from each collision. But those pesky particles don't always scatter in the way they're expected to. This is a bit complicated for the average reporter. Fortunately, there's always the analogy.
This is an example of a complicated atom with lots of electrons whizzing all really, really fast around a central nucleus somewhere in there. Now, experimentalists, they fire other electrons like this.
This is an electron.
This is another electron, and they fire it at the atom. And they measure the electron to work out all the properties of the atom.
So you fire an electron and it bounces it off, and what? Your theory is trying to predict where it's going to land.
Yes, so unlike experimentalists, I don't actually ever go into a lab. I try to predict theoretically using the computer what will happen when you scatter electrons from atoms.
Oh, let me see if you can predict this.
No, I couldn't predict that. I thought you were going to sink it.
Predicting the pattern of electron scatter of even the simplest atom, like hydrogen, requires thousands of simultaneous equations with an extraordinary number of variables. Doing it by hand would take 15 billion years, give or take a billion. But the arrival of cheap and very fast computers in the 90s made such large calculations possible and allowed Igor and his friend Andris Stelbovics to develop a mathematical theory that explains electron scattering. Calculations that would take days and weeks.
These are the machines used by Igor and Andris when they began working on their theory in 1990. 64 megabytes of memory, enough for 1,000 simultaneous equations to be solved. Within a couple of years, memory had quadrupled, and they moved on to these, able to complete 5,000 simultaneous equations at once.
After years and years of running simulations, their theory was looking pretty good. But the results the theory predicted looked nothing like the data collected in the real world, the world of physical experiments. Especially 2 landmark experiments in the 1970s, which completely contradicted Igor's figures.
Well, how did you feel?
Well, I was very depressed. I was So depressed, in fact, that I considered leaving the field. The situation basically was that if theorists could not reproduce experiment for the simplest electron-atom scattering system, that is, electron on atomic hydrogen, then they might as well give up.
But Igor didn't give up. He persevered and spent the next few years refining the theory. When he was convinced it was right, he did something you just don't do in physics. He said the theory was right, and it was the experiments that were wrong.
So teams around the world repeated the 1970s experiments. They had thought they would shoot down his silly theory. Instead, only a few months ago, they actually confirmed it. When the new, more carefully conducted experiments were compared with Igor's predictions, the result was a bullseye.
And here are the results.
My gosh.
Similar results as the previous experiment at the small scattering angles, but at the large scattering angles, we've got now positive values in complete agreement with our theory. This was a considerable source of joy.
So I guess you stayed in the business.
Yes, I've stayed in the business. I'm glad I stayed in the business, and I'm going to stay in the business now for a very long time.
These days, working from his home in the Adelaide suburbs, Igor gets free time on some of the best supercomputers in the world. He's a consultant to NASA and the International Atomic Energy Agency, and is in high demand for collaborative studies. But he still finds time to tackle the really challenging problems.
Down to this little corner and you press. Well done. So this is a picture of the helium atom in an excited state. It's called a singlet 3p state.
Dad, I like a baseball game or something.
Right. I don't think we have got a baseball game on our computer. Electrons are coming in along this red line, and the detector is moving across forward.
The hardest thing by far is parenting. That is by far the hardest thing. Followed by golf. I mean, golf is not as hard as parenting, but it's pretty tough. Physics and mathematics, I think, are one of the easier things in life.